Mance, welcome to Real Vision.
Hi, Ash. Thank you for having me.
It's such a pleasure to have you here. I interviewed your co-founder, Leemon Baird, 2, 3 years ago, so long ago that I don't believe it was called Hedera Hashgraph yet.
That's possible. There was a lot of talk about the project before we revealed the name. So yeah, that's quite possible.
Yeah. You've had a long and distinguished career in technology. You've worked at some very big, well-known companies, including Motorola. You taught computer science at the Air Force Academy. And you have one item on your resume that I'm sure that everyone asks you about, but I'm just intrigued by it. You were program director at the Missile Defense Agency for the Missile Defense War Games project, I should say, at the Missile Defense Agency.
No, that's right. So, a lot of your viewers might remember the movie War Games from the 1980s. Matthew Broderick was the star. I managed a program that built sort of the real thing. We it was a massive simulator that made it possible for the U.S. and its allies to play war games, to figure out how to protect our populations and those of our allies from incoming ballistic missiles. And it was a great experience. I'm just honored that I was able to contribute in that way. And it was a fun 2 years for sure.
Yeah. Every guy or gal who's about my age watched that movie growing up. And if you were interested in technology, it was like a touchstone for nerdiness and something that I think probably had an impact on lots of people in my generation. But it is also interesting to think about some of the parallels, perhaps, large networks, distributed sensors, distributed information. Tell us a little bit how you got interested in distributed ledger technology.
Well, it's interesting you say that because it's correct. I mean, my co-founder, Leemon, who you mentioned earlier, and I have been working together for a really long time, since '93. And a lot of the projects, coincidentally, had some element of decentralization involved in them. You mentioned one that was sort of a distributed collection or network of sensors, and I'll call them actuators. They're really weapon systems for shooting down missiles, that sort of thing. But then we started a company in the space of identity and access management. That was our first company. And we built a decentralized, think of it as a fancy password manager for enterprise, where the management of the password database for an enterprise didn't happen in a central database within an enterprise. It was distributed across devices. And we've had those kinds of sort of ancient, 20 plus years ago experiences. Leemon went to work in 2012 to solve a really hard decentralized math problem, or distributed consensus math problem. And that problem specifically was how to create a consensus algorithm that both maximized performance and maximize security simultaneously. It's been a decades-old problem. I mean, it's been clear how to have the best security in the world. There's a term for that, asynchronous Byzantine fault tolerance, but it's always come at the expense of resource requirements, bandwidth specifically. The more computers you add to the network, the more bandwidth that's required, so it never would scale. Leemon wanted to solve that problem, and he did in 2015. He created what today we call Hashgraph. And that
what we're showing you here on our YouTube channel is just the tip of the iceberg. No matter where you are in your financial journey, whether you're a beginner just looking to break into the market or a financial professional looking to up your game, Real Vision has something for everyone. Every day, our team of expert journalists provides in-depth analysis, written reports, access to live streams, and access to our community, The Exchange, where you can interact with people just like you from all over the world. For just $1, you can unlock all of this and more at realvision.com. Try our Essential tier. If you like what you see, it's only $20 a month thereafter. So click on the link in the description, go to realvision.com, and see what you think. We look forward to seeing you there.
That's required, so it never would scale. Leemon wanted to solve that problem, and he did in 2015. He created what today we call Hashgraph, and that sort of led us down this path of building now a public distributed ledger that is based on the Hashgraph algorithm with these fantastic performance and security properties.
Yeah. One of the great things about Real Vision is that we have the time to delve in some detail to cover some of these topics. So let's talk a little bit about the nature of asynchronous Byzantine fault tolerance, the challenge itself, and then virtual voting and how Hashgraph solves those problems. Talk a little bit about the nature of the challenge first, if you would.
Yeah, well, the problem is, so you can create a consensus algorithm that makes it possible for the participants in the network to vote on the order of transactions. And the problem is, as the number of transactions goes up, the voting that's required, just sending the votes to every node in the network, the bandwidth requirements for that go up exponentially. And that's been the challenge. So the question is, how, hypothetically, could you build a consensus algorithm in a network that had the same properties, but didn't require the participants to send their votes to each other? Cut out that bandwidth requirement. The innovation here, the insight that Leemon had, was that when you create a transaction, let's say Alice wants to pay Bob a token, an HBAR in our case, when Alice creates that transaction and she sends it to the network, along with that transaction is a little bit of information on top, namely the last transaction that she created and the last transaction she received. So the last one she created prior to this one and the last one she received, not the full transactions, but just a hash of each. That's a technical term. It's just a digest of the information to make it really tiny. But if you include that information, when you submit the transaction, everyone does the same thing. When anyone is creating transactions, they include those two pieces of information. Then it becomes possible for everyone in the network, all the nodes in the network, to take all of that information, those hashes, and chain them together into a graph that represents, basically, conceptually, represents who knew what and when they knew it. That's the hash graph. And so all transactions flow in. Every node in the network receives every transaction, and they use the metadata, those hashes, to create their copy of the hash graph that describes the flow of that information across the network. And then you've got enough information. This was the insight. There's enough information in this hash graph that you can use one of these consensus algorithms, voting algorithms that I've mentioned, but instead of asking Bob how he would vote on the order of two transactions, you can look in the hash graph and you can just calculate what Bob would answer if you were to ask him the question. You don't have to ask him. All the information is there. All nodes in the network have exactly the same information, identical information. They all use the same consensus algorithm. And then they all can run this consensus algorithm on their local copy of the hash graph and calculate what every other node in the network would vote if they were to ask the question, how would you order this set of transactions? And they all come up with the same answer. That's virtual voting. And that's the innovation. He solved the problem of cutting out the bandwidth requirement by going to virtual voting, but maintaining the fantastic properties of voting algorithms, asynchronous Byzantine fault tolerance, simultaneously, and it's just brilliant. That's how it works.
Yeah, it's really a fascinating concept. And, our viewers may notice I use the phrase DLT, distributed ledger technology, at the beginning because Hedera Hashgraph, or I should say, Hashgraph is not a blockchain.
That's exactly right. So where blockchain is a term that represents both a data structure, a chain of blocks of transactions, as well as a consensus algorithm, how a community can come to agreement on what block to put on top of the chain next. Hashgraph is similar. It's a term that describes a data structure. In this case, it's not a chain. It's something called a DAG, a directed acyclic graph. Technically, that's what it's referred to as. And a consensus algorithm that allows the community to come to agreement on the order of transactions that are represented in this graph. Similar concept, fundamentally different approach to solving the problem with better performance and better security.
Talk a little bit about those performance and security issues, and why, in your view, hash graphs are superior.
Well, when you hear a term like asynchronous Byzantine fault tolerance, the asynchronous piece here becomes important. Byzantine fault tolerance just refers to the idea that it's possible for a community of nodes to work together to come to agreement on the order of transactions. If you don't have the asynchronous part describes what assumptions are being made in a potential attacker, a would-be attacker on the network. And what the asynchronous part means is that no assumptions are being made. No limiting assumptions are being made. And when I talk about assumptions, it's an assumption like, if you don't have asynchronous BFT, if you're just BFT and provably BFT, that means that you have to assume that there's no such thing as a distributed denial of service attack. It's a very common type of cyber attack in cybersecurity. You have to make assumptions like there are no firewalls in your network that could be attacked. Well, those things exist in the real world, and you have to address them somehow. And asynchronous BFT means that you don't make those assumptions. You assume that the attacker can pretty much control the internet. Even in the face of the attacker controlling the internet, you can prove that the nodes will eventually come to consensus on the order of transactions. That's why the asynchronous component is important for BFT. In terms of performance, look, first generation tech, if we think about blockchain Bitcoin and Ethereum as first generation tech, Bitcoin can process 7 transactions per second globally, and Ethereum currently is at 15. And that's because of the proof of work consensus algorithm, the blockchain consensus algorithm that they use. Today, on the Hedera public network, in the beta version that's being used today, we have capacity for 10,000 transactions per second. It's just orders of magnitude difference. The way I like to describe it is there's a set of applications that you can use if all you have is a calculator. A calculator can solve a certain set of problems. But if you move from a calculator to a computer, the range and scope of problems that you can address is much broader. And that's the difference between that first generation blockchain technology and Hashgraph.
Yeah. And I should say, with regard to the constraints on things like Bitcoin and Ethereum, just to give a bit of context on what these numbers mean, Visa now claims to be able to process 65,000 transactions per second. So you're dealing with these massive order of magnitude differences between traditional blockchains as they stand today and what the sort of state of the art in the private sector is for transaction processing. And as you begin to move closer to that number, obviously there are possibilities that come for real world applications of distributed ledger technology.
That's correct. And that's where we're going, right? The network today is beta version, meaning that we've throttled down the number of TPS. As we scale, we will increase the network through something called sharding, and we'll remove that throttle as well. And so both will be able to, within the single shard, the first network, which we'll talk about today, that's run by the council members, that TPS will go up. In addition, there will be other shards or sort of sister networks that are talking to each other in one big system that allow us to scale to many millions of transactions per second.
Millions of transactions per second.
Oh, absolutely. For certain types of usage patterns, the more shards you add, the better you can scale. It's not always true. There's certain types of usage patterns that don't benefit from additional sharding, but for a lot they do.
Yeah. And I understand you just passed a milestone in terms of transaction count quite recently.
We did. So, two milestones, in fact. About, I don't know, a month and a half ago, we crossed 1 billion transactions. That was a big milestone for us. I think the noteworthy piece of that is that we did it in about 18 months. The only other chain at that time that I'm aware of that had crossed 1 billion was Ethereum. And just within the past week or two, we've now surpassed Ethereum in terms of total transactions processed. And again, only in about 18, 19 months.
This is a pretty extraordinary figure. Tell us a little bit about what those transactions are and how they're being used right now.
Well, what they're not is a bunch of cryptocurrency transfers. So I think that I want to make that point up front. The vast majority, I don't know the exact percentage, but far and away, the network is being used for actual applications that are high volume applications that you simply would not be able to address in the first generation tech. Not just because it's slow, but also because of the expense. Our cost per transaction is a fraction of a penny per transaction. When you compare that to the first generation technology, it can be tens of dollars per transaction. So it's another limiting factor with that first gen tech. But our use cases, not surprisingly, are typically high volume use cases. AdStacks is a good example. They are a company that is addressing ad fraud in the market. Another great example is the Coupon Bureau. The Coupon Bureau is an industry consortia for the coupon industry. Large companies like General Mills and retailers like Target and others have created a new standard for digital coupons, and they're using our tech at the point of sale to record the fact that a coupon has been used and collect analytics. And that information can be distributed across the entire ecosystem of participants in the coupon industry. And that will be scaling up later this year as well. It's these types of large ecosystem plays where there are entire business networks that have a solution that they want to take to market, that they're building on top of us, that are really high volume and really high value. And that's what we wanted to enable from the beginning. A platform that was capable of addressing use cases from small and medium businesses all the way up to being completely enterprise grade, able to support enterprise transaction volumes with enterprise security requirements.
And these business transactions are taking place in production today.
Correct. Yes. So even though the network is considered beta, it's hardened and is being used by I don't know how many applications or dApps are actually deployed on us now, but it's a lot. It's a lot of applications that are, and we're learning about them every day. I mean, that's the nice thing. We're at the stage now where we're being surprised to hear about applications that have been built on top of the platform without our involvement at all. And I think this is the early stages of recognizing the network effects that are bootstrapping the platform and now having an effect.
Yeah, it's so interesting. Can you give us some examples of these use cases where it's being used in production on dApps, just to give us a sense of what some of the possibilities are?
Well, if we think about tokenization, let's start with tokenization. When I say the word tokenization, just to be clear, what I mean by that is any asset that you can imagine, anything that has any real value. It could be physical, but it doesn't have to be. It could be, the asset could be a contract, or it could be intellectual property. Anything that has value could be tokenized, meaning that there can be a digital representation of that asset that carries along with it rights of ownership, perhaps governance rights, rights to dividends or some type of revenue stream, it's arbitrary in terms of what you might be able to do with that. We have a council member, the DLA Piper, global law firm, one of the largest in the world, that has created Toko, which is a tokenization issuance platform. They make it possible for their customers to create arbitrary tokens that represent these assets and go to market with them and issue those tokens on our platform. So that's just one example. And there are others in that same space. Suku is another partner customer that is in the tokenization space as well. So tokenization is there. Supply chain is there. We have an organization, a partner that has gone to market with a supply chain tracking system, track and trace solution for pharmaceuticals for the country of Bahrain, as an example. There's another partner that's using track and trace capability on the platform for tracking the COVID vaccine for the national healthcare system in the UK. Specifically, their packets or boxes that have to be refrigerated that contain the vaccine. And there's temperature measurements on those boxes. If the temperature ever gets too high, then the vaccine has a very short shelf life and it needs to be used immediately. And so this telemetric data, the temperature data, is being recorded and captured through us so that there is a provenance of the temperature related information associated with these crates of vaccine for the NHS. Everywhere is the organization that's doing that. Those are just a few. And the nice thing is, again, the breadth of use cases that we're seeing is quite broad. Tokenization is a big theme. Supply chain is a big theme. And many others as well.
Well, that's fascinating. The idea that these real world use case scenarios are taking place right now, today, in production and in mission critical, healthcare type scenarios where, if there is an inaccuracy, the outcomes can be incredibly negative. I think a lot of people out there who are just viewing this space from the 50,000 foot level believe that the only thing that can be done with distributed ledgers today is speculating on tokens and then hoping to sell them tomorrow for a higher price to someone else.
Well, that's certainly a lot of hype out there, and that's a lot of focus of attention for a lot of people. When we started the organization in 2017, we made the decision then that we wanted to build a company that was going to be around for 100 years. 100-year network is what I should say. That's what we are. We are a network that is governed by some of the largest companies in the world. The decisions that we've made from the beginning are to that end. Is let's build something that's going to persist and be of great value for generations to come. And we've tried to steer clear of all the hype and just focus on the fundamentals and making sure that this network provides the infrastructure that's needed for the real world use cases that we know are going to emerge. And now we're beginning to see that.
Let's frame that a little bit, because for me, the other thing, aside from Hashgraph, that is really novel about what you're doing at Hedera is the governance structure, the idea of how you've basically put this network together. It's very different than something that we would see in, for example, Bitcoin. Tell us a little bit about the first principles that you put in place to think about this. I know you've talked about the 3 broad categories of governance. Tell us a little bit about your intellectual framework for how you reached this decision.
Honestly, it started by reading a book, believe it or not. There's a book written by a gentleman named Dee Hock. Dee Hock was the founder of the Visa network before it was Visa. It was Bank Americard back in the 60s, and then they changed their name to Visa. And he wrote a book about his experiences when trying to create this network where all the individual participants had to give up control and work collectively for the benefit of the whole in this first decentralized governance structure. That was the inspiration. I literally took the book and a yellow marker highlighter and highlighted the governance model that they created back then. And we started there and then we adapted it. But the first principles that you mentioned are really pretty simple to understand. When we think about governance models, and when we talk about governance, just to be clear, in this context, what I'm referring to are the decisions that are made related to the project. For example, what's the product roadmap for this infrastructure that we're talking about, this network, this software that runs it? There are features associated with that. Who makes the decision on what features go in next, and what's that roadmap look like? Legal and regulatory matters. We're a global organization, a global network that operates in jurisdictions around the world. It's quite a complex regulatory environment. Other things like use of treasury. That's what I mean when I talk about governance. And in that context, you can think about three top-level models for governance. One, you could have a dictator, and there are advantages and disadvantages to having a dictator. One is that you can operate very efficiently. Assuming the dictator is benevolent dictator, then you can have a reasonably well-run organization that is sort of the standard approach today in the world of business.
We have this term, and for people who are not familiar with the computer science open source world, BDFL, benign dictator for life. It's generally used in regard to open source projects, but that's sort of the idea. And obviously the advantage, as you suggest, is efficiency and speed of execution. If you have one person who's a trusted entity, it's very easy to go to them and have him or her make these decisions in a very rapid way.
Exactly. And that's sort of the standard model. The whole world of distributed consensus, distributed ledger technology, this ecosystem that we exist in, wants to move away from that. And if you're moving away from that, then it's a question of degree. The other extreme is pure democracy, where everyone that has some level of interest has a vote. The problem with the pure democracy is that it doesn't really work well if the decisions that are being made are quite complex. If the decisions are really simple, then yes, if you don't have to be an expert in whatever the decision subject matter is, then great, pure democracy works well. Right. On the other hand, if we're talking about the kinds of decisions that I just described, you really need experts. Right. And so there's sort of a middle ground there. I just refer to it as sort of a representative democracy.
Well, we should also, just to give people a context for this, understanding what the pure democracy model looks like. Uniswap would be one example. If you go up on Uniswap, there'll be the ability to vote on various proposals. You vote based on it. All votes are weighted equally, and then the outcome is based on the voting. You can sort of see an almost modified version of this in the Bitcoin space, where you have these, you have proposals, but you also have multiple categories. You have infrastructure providers like CoinDesk. You also have, obviously, the miners who get to accept or not accept different proposals. So in practice, it gets a little bit, well, let's just say complicated.
It does, exactly right. And there are variations on each of those models. In a pure democracy, some forms that we've seen in the market, there's something called a governance token that's associated with governance rights. And the more governance tokens you have or hold, the heavier, the weightier your vote is in the process.
Right. And again, that's a pure democracy in the sense that you have basically a weighted vote based on the tokens, but obviously those tokens aren't evenly distributed. So again, a lot of complexity in the way that we think about it. That is to suggest that one model is right or wrong, but it's just a very complicated question.
That's exactly right. And I think that the governance token approach is not a bad approach, with the obvious downside. If there is an organization or an entity that can buy up more and more of those tokens, you could hypothetically end up in a situation where you don't really have distributed or decentralized governance, or at least it's not as decentralized as you might hope it would be. And so you have to put in controls. How do you prevent that sort of thing from happening, this decentralization of voting weight? Our approach, again, goes back to sort of what I saw in Dee Hock's book. Our approach was to create a council of world-class organizations that provide the governance in question. And the council members each individually get one vote, and that's it. There's no additional weight or more or less weight on the governance of the network that we're describing. And then the way we created it, when we envisioned this, we wanted to make sure that the council was representative of the entire universe of use cases and geographies or jurisdictions. So we didn't, for example, have a bunch of banks join us. There are a couple banks. There are 3 banks now: Nomura, Shinhan, and Standard Bank out of South Africa. But that's it. And then there are some tech giants, and there are some payment companies, and there's retail, and there are law firms. But the point is that we wanted to be decentralized across industries or distributed across industries to get this global view on what's important for use cases, and not decentralized within a single geography, as I've mentioned. So it's a global view. And then finally, the council members are term limited. They're, in other words, decentralized through time. A council member can come in, they can participate for up to 2 3-year terms for a total of 6 years, and then they have to leave. Now, that doesn't mean they have to leave the Hedera ecosystem. It's just they're no longer a governing council member. And that then allows for other organizations to join us, and it keeps the dynamism and the ability to continue to see what's going on a global scale and what's important, and have the decentralized governance through time. And that's the approach. There'll be 39 council members. Ultimately, we're at 21 today. We just added our 21st council member. In fact, by the time I think this is aired, that will be announced. It's Chainlink. It's our first council member from the crypto space. We have not added another crypto-centric council member until now. It's always been, large, top-ranked educational institutions like UCL out of London, or Fortune 500 organizations. And we're, delighted that Chainlink is now our first crypto representative to the council.
As complicated as some of the math and computer science problems are, some of the most complicated problems in the world are the ones that invariably involve human beings. So I'm curious, what's the process for nominating and approving council members? How does that work?
Frankly, we had to start from zero. And it was me and Leemon literally beginning to execute on this vision of creating the council, which means necessarily that we made choices. We created sort of an internal set of criteria. They had to be the best brands in their industries. Trust was incredibly important to us, market trust in these organizations. It's not just about the market trust and wanting the largest companies by organization. There is an element of, believe it or not, mathematics behind us, a mathematical justification or requirement, frankly, for going with this caliber of organization. As crazy as that may sound, it's actually true. And so, the math drove some of that.
Tell us about what some of that math looks like.
Yeah, it has everything to do with coin economics or token economics. When you have a brand new token like ours, and you're a proof of stake system, the way it works is you have some number of computers, each voting their pro rata weight of the total token supply. So in our case, we have 50 billion tokens that got minted. 50 billion tokens. When you're creating the network, you're standing up the network, each computer has represents some portion of that token pool. And when they vote on the order of transactions, the weight of their vote is a function of the number of coins they represent. Now, if you started with just say 10 or 100 of your friends or small organizations. Each one of those organizations or individuals has some pro rata portion of the weight of the tokens. The token has some value in the market. It's so there's a float. Some portion of it is listed in the market. And when the token price is really low, and the market can, more importantly, not token price, to be more technically accurate, when the market cap is low on the token price, on the token, then a bad actor could more easily go in and buy up at least a third of the supply. And if they're able to do it, this is where the math comes in. If a bad actor is able to control a third or more of the total token supply, then they can prevent the network from operating or functioning appropriately. They can prevent it from coming to consensus.
For those who may not know, this is the 51% attack, being able to have a majority of a 51% stake.
Yeah, so there are various ratios for different kinds of attacks. But if a bad actor can buy up a third or more, then they can affect the operation of the network. As the value of the token goes up and the market cap gets large, then the market has to ask itself, do I trust this set of nodes not to, quote, steal the money? And of course, the higher the value goes, the more motivation there is for this group that represents controlling interest of the total supply to do exactly that. And so you can't easily bootstrap. You got to have trust in those that are controlling at least 2/3 of the total supply, which means you have to do something like what we did. You go with the largest organizations in the world. They care far more about their brands, their brand equity in their core businesses than they do about this network, to be blunt about it, right? And they're geo-distributed and they're cross-industry. That's not very likely that this collection of organizations is going to, quote, steal the money. And so it's all about instilling market trust in those that hold a controlling interest of the token supply until the token supply can be broadly distributed into the market and the market cap is high enough that no bad actor can go in and buy up a third or more of the supply. That's how it works.
Mance, you talk about the largest organizations, some of the largest organizations on the planet, and the most trustworthy for that reason, who have an incentive, obviously, to not take off with the cash, so to speak, to do the right thing in terms of doing the trustworthy thing for the network. How do you operationalize that technically? What's the structure that's in place? How do the validators work? What's that system look like from a technological standpoint? What's the bridge between the two?
Right. When we think about decentralization, I think of it really in two dimensions or along two axes, if you want to consider it that way. One is the governance. And we've already talked about the governance model and how that works. And I could talk about more of the details of how that works, operationally. And then second is the consensus, the ordering of transactions technically, a technical level. The nodes are each operated by the different council members. So each council member is running a node, and this collection of nodes is operating the Hashgraph algorithm along with the services that we offer. And when transactions flow into a given node, those transactions get put into consensus order by this community of nodes that are operated by the council. So at a technical level, that's how it works. That's phase one. We will be adding community nodes to that group of nodes. We're bootstrapping with the council nodes. We'll add community nodes. And then ultimately, we will allow anonymous nodes to participate as well. But that's sort of the last step in this process. In terms of governance, it's sort of like a standards body in some ways. The council members, technically, they're all members of an LLC, we're a Delaware-based LLC. When we add a council member, it's not just a marketing agreement. It's the real deal. They've joined an LLC to operate with us. But functionally, there are council meetings where we discuss various issues and use cases. That's part of the value here, is that the council members end up collaborating and working together. In terms of governance itself, there are committees. For example, there's what we call RegCom. It's a regulatory committee. There is TechCom, technical committee, and those types of committees that have oversight, policy-making authority and oversight of the different parts of this network, the organization. There's a board of managers. I report to the board of managers. So we created this organization. We created the board of managers. I report to them. If they wanted to fire me tomorrow, they absolutely could do that. All right. They have control. The council has control, and they set the policies and they make the decisions. And the Hedera staff merely executes that policy and operates what I like to think of as an operating system, this distributed ledger operating system that's built on Hashgraph. And that's how it works.
I'm curious. I know that this hasn't been operationalized yet, but you talk about the potential for community nodes, anonymous nodes in the network. What's the theoretical role that they will play? What value will they add in terms of managing transactions and ordering transactions?
Yeah. Well, there are a couple of things. One, it just increases the capacity of the network. When we have a single shard like we do today, ultimately there'll be 39 nodes in that shard. Maybe we'll add community nodes to that shard. But a shard is going to at some point be limited in the number of transactions per second a single shard can process. To scale, we will end up needing more shards. We'll add more shards, and each one of those new shards needs its own collection of nodes in the shard to process the transactions. So the community nodes come in, anonymous nodes will come in to that picture as well. So just in ordering of transactions, we need the nodes to scale beyond where we are. But the nodes themselves, they're all identical. The software that an anonymous node runs versus a community node versus a council member node, there's zero difference. It's exactly the same software, and there are no master nodes or nodes that have more control or anything like that. It's all on a level playing field, and the weight of their vote on the order of transactions is a function of the number of tokens that node represents. So it may be that there's an operator of a community node, hypothetically, that represents, I don't know, let's call it 1 billion tokens, just to pull a number out of the air. They represent 1 billion tokens. If that were the case, then when they vote on the order of transactions, their vote represents 1/50th of the voting weight because there's 50 billion tokens. And that's how again, it all goes back to the math, and that's how it works out.
Something you touched on earlier that I'm curious about is the legal structure of Hedera. How is it actually implemented as a company? I think most people are familiar with the model where you have shareholders, a board of directors who hire managers who then execute the will in theory of the shareholders and the owners of the company. How does that actually work as an operating entity and as a legal entity?
In this case, the LLC structure really is in place primarily just for liability protection. The bylaws are set up so that if Hedera has more transactions flowing in, when a developer uses the network, they call an API, an application programmer's interface, with their software calls an API on the network to request the use of a service. When that happens, they pay for the service with HBAR, our cryptocurrency. That's the revenue stream. You could think of it that way. However, the bylaws are set up such that the council members don't get any revenue. There's no dividends that are associated with participating in this way. It's not the case that Hedera's, certainly not my expectation, that Hedera will turn into a for-profit organization. Legally, it's an LLC. Functionally, it's more like a nonprofit or a not-for-profit. And the node operators ultimately get paid to process the nodes. They have real costs. The node operators generally will be paid to cover those costs and ideally make some profit on top of that. But that's independent of whether you're a member of the council or not. So it's like a standards body, but also operates sort of as a nonprofit. And each member has a single vote. There are no heavier weighted members in that context. And it's just a decentralized governance structure.
Yeah, it's really fascinating. It's a novel idea and something. One of the challenges with having these conversations in general is just how big these ideas are and how different they are from the way that we think about the world as it's been practiced. If you went and got an MBA in the year 2000, you learned a very different view of the way companies, for example, make their decisions. So it's interesting to think that you have Hedera staff ultimately who are directing the day-to-day activities, and you guys are responsible to the council members.
We're responsible entirely to the council members. The staff executes on the creation and operation of, again, this operating system, which, by the way, is not where the value is created, right? I think it's an important point. If you have an operating system that has no applications running on top of it, what value is there? Zero, right? All we do is create and operate and maintain the operating system. But we are entirely subject to the decision of the council.
And then that takes place, of course, on a rotating basis. So that will be in continual change as you move forward.
Right. When we started all of this, I had a lot of people tell me, Mance, you're crazy. It's hard to get two enterprises work together. You're wanting to get 39. That'll never work. And, here we are several years later, and we're more than halfway there. And we've gotten some of the biggest companies in the world to participate.
Yeah, it's just absolutely fascinating. It's almost like Theseus's ship, right? You're rotating through council members who have the governance capacity over the staff, and then you're going through it. It's just such an interesting structure and such an interesting idea.
There's that. There's one other motivation I didn't describe that I think maybe is relevant. When creating something like this, ideally what you would want is the very best expertise in the world advising where it's relevant. And the models that started, the platforms that started years ago, sort of first generation models, had a group of software developers that created something fantastic, right? They built a piece of software that was really cool, and they are the governance model. You have a dozen core developers that are deciding what goes into the baseline. Even if there are 1,000 developers, in reality, nothing goes into the baseline unless one of those core developers approves it, which is of some value. But we identified that we needed a lot more value than that. We wanted global experts in law, global experts in tech, global experts in, you name it, variety of functions across the organization, and by committee, where those organizations that are council members want to participate and have the expertise, they do so. And because of that, we get fantastic oversight and advice from global experts in every part of the network.
Yeah, and I believe the original Hashgraph papers that Leemon worked on were also peer reviewed. So this is also part of an open sort of community driven academic project as well.
That's right. The papers have been published for many years now. The code is not, the algorithm's not just published in a paper. It's been proven, formally proven in the mathematical sense. Basically, there's a way to prove that the consensus algorithm has the properties that Leemon claims it has, and then the proofs themselves can be checked by a computer to be accurate. So yeah, it's all hardened and real in some of the most rigorous sense.
Yeah, it's interesting. One of the themes that keeps coming up again and again throughout your long career, and also through Lehman's, who's got a strong defense and military background as well, is this idea of trust. I imagine at the Missile Defense Agency, you must have unbelievably high requirements for security clearances and that type of oversight. So it's interesting to see how these ideas that you've been thinking about for decades sort of go through this system.
Well, we certainly learn to never cut corners. When you're doing something of that importance, where countries depend on accurate results and the populations of those countries, you don't cut corners. And that's sort of been the theme through all the work that we've done in our careers, starting with the military, multiple organizations in the military, and then sort of taking that same ethic and applying it here in the business world for sure.
So we've talked about a lot of very big ideas here, big themes, some really, I think, seismic changes in the way that we think about things like business, commerce, transactions. As we come to the end, give us a sense of what some of the key takeaways are that you'd like to leave our viewers with.
Well, so I think that the world is changing, and it's going to change very quickly. The momentum in the industry has been building. A lot of infrastructure has been being built without the market yet being able to take advantage of that and build the business applications on top, which is where the real value gets created, not in the operating system like what we built, but you have to have the operating system to get there first. And we're now seeing that in a sort of a confluence of three major trends. One is DeFi, the decentralized finance, which we've not really talked about today, but this notion that you can have finance componentized in software and then embed it in digital workflows. That's really a big, it's another big story, another big vision. And I think it's going to be incredibly important in the future. But DeFi without tokenization doesn't work. And we talked about tokenization very briefly. The world's going to be tokenized. Everything you see and touch is going to end up having a token, a digital token that's associated with it. Everything that flows through a supply chain is going to have a token associated with it. Contracts, IP, et cetera. The world is going to be tokenized. The result of that is going to be that the ownership and the transfer of these tokens, the value of having tokens in the first place is it reduces the friction and the transfer of of these rights from one party to the next. When you can, if you can reduce that friction enough, then it gives rise to new business models and new types of marketplaces, specifically decentralized marketplaces. So the creation of, or the world going tokenized in combination with DeFi is going to give rise to decentralized marketplaces. It's going to change the way the world does business in ways that, we're only now beginning to understand the mechanics of, and I'm sure the vision is going to, it's going to expand as we get further into it over the next few years.
Yeah, that's very well said. And, one of the things that we're committed to doing at Real Vision is to talk about what this digital future looks like. And truly, at Hedera Hashgraph, you are approaching things in a very different way from what, for example, we would see in the Ethereum ecosystem, in the Bitcoin ecosystem. This is really something new under the sun. And I'm so glad you could join us to discuss it.
No, well, thank you, Ash. I appreciate your interest and very happy to be here. Thanks for having me.
Thanks for joining us. And thank you for watching, everyone.